Welcome to 1.2 Measuring Segments Notes. So what we're going to be looking at here is there's a couple different ways that we use this ST symbol. So ST with the line over top of it is saying segment ST, whereas just ST with no line over top of it, that's talking about the measurement from S to T. S to T. And so in this case, that number, we were actually going to come over here and measure the distance from S to T. So segment S to T is talking about the actual visual thing, the image, whereas S to T, the measure of ST, is actually a number. So we can see here in this image, we're going from -4 on this number line to +8. So if we can kind of count over, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12. We can count it that way, or you can do some subtraction here, going from -4 to 8. So like 8 minus -4 would give us +12. And so the measurement from S to T would be 12. So that's the difference between the segment itself and the measure of that segment. So if we come down here, what this is telling us here is that the measure from A to B is 4 centimeters. So that is 4 centimeters. And the measure from B to C is also 4 centimeters. All right, so we get into this idea of what is equal versus congruent. So equal is when we're talking about measures or quantities. So when we're talking about equal, we're dealing with numbers. All right, congruent is the idea that two segments are, if two numbers are the same, they're equal. If two pictures or images are the same, then we say that they're congruent. So that's the difference between those two terms. So congruent is for pictures or images. So that is pictures. So we can have congruent segments. We'll get into congruent shapes, congruent objects, things like that. 4 is equal to 4, so we would say that AB is equal to BC. So that's the statement of equality. Whereas if I kind of want to do it in terms of congruent, and this is those two lengths, those two segment lengths are equal. If we say that this triangle is isosceles, and we'll assume that they're talking about those two sides being congruent. So we do these little lines across segments to show that they are congruent. There's other little congruent markings we'll do, but by putting those two little lines there, I'm showing that those are the two segments that are congruent. That means they have equal length, but the segments are congruent. So if I want to write that statement, I would say segment AB, and then the congruent symbol is a lot like an equal sign, just with a little tilde, little approximate symbol over top of it, little curvy guy, and that is congruent to segment BC, or you could have said CB. Or in BA, a couple different ways we could say that. But that would be our congruence statement. All right, so with measuring segments, we can talk about the midpoint of a segment. That's the point that divides the segment into two congruent segments. All right, so if we wanted to draw a picture of this, A is the midpoint of CT. Well, let me start with CT. So segment CT. If A is the midpoint of that, it would be halfway across, right? So right there, and so that would be point A. And we would know that these two segments are congruent, which means they have equal length. But that's how we would find that, or that's what that midpoint definition is. All right, a segment bisector, similar, but it's not just necessarily A point, it could be a line or array that intersects a segment at its midpoint. At its midpoint. So I should not have had apostrophe. Getting confused there. All right, at its midpoint. So the point would actually just be the A, but you can also bisect a segment with a line or array. So here they've got KE. Notice that there's an arrow at just one end of that, so they're talking about ray KE is the segment bisector of JO. So I'm going to start with segment JO, and then we'll bisect it. So JO, and sorry, not a very good drawing, but the midpoint there. So my ray could start at that point. My ray could start there, and this could be actually K and then E out here somewhere, or I could even have my ray down over here somewhere. So I'm going to do it this way, but there's a couple different ways this could look, and it can go at any angle. It doesn't have to be perpendicular or anything like that. But I'll start here with this as K, and then the point E could be there. I could have some other point over here. But ray KE bisects this so long as these two segments are congruent from J to whatever that point is, and then from that point to O. So that would be bisecting a segment. All right, so it's simple of a problem that you could see with something like this. O is the midpoint of DG, so we know that O is the midpoint of DG. It cuts that into two congruent segments, so we know those two segments are congruent. And then they tell us the measure. We got some algebra coming in here. DO is equal to that, so the measure of DO. So this length, that measure, is 6x minus 7, whereas the length from O, or the measure of the segment from O to G is 5x plus 1. So what we know, since these two segments are congruent, we know the two measures are the same. So ultimately they want us to find the length of DG. All right, well, first thing that we can say, we know that these two segments, since they're congruent, that their measures are the same. We know that 6x minus 7 is equal to, that measure is equal to 5x plus 1. And yeah, we get to do some algebra. So solving an equation here, we want to isolate x and figure out what x is, because we can actually get this measure figured out, the exact number for that measure. You can figure it out in terms of x, but the intent of this is that you can actually find that numeric measure. So because we know these lengths are the same, we can figure out what x is, doing a little algebra with this part. So isolating the variable, we want to get the x is the same, so I'm going to bring 5x over minus 5x on both sides. So that'll cancel on this side. We'll end up with x minus 7 when we 6 minus 5 equals 1. Add the 7 to both sides. And so we're going to get that x is equal to 8. All right, we can double check this this work here. So if I plug 8 in for this x up here, change colors. So if I plug 8 in, this would be 6 times 8, 48. Minus 7 is 41. So that measure would be 41 if I plug 8 in. This measure over here, 8 times 5 is 40. Plus 1 is 41. So yeah, both those lengths are 41. So DG, I could get that by just adding those two up. The DG's length would be 41 plus another 41 gets us up to 82. So 41 plus 41, DG's measure is 82, coming from 41 plus 41. You also could have done this a little differently. You could have actually added those first. So let me show that alternative here. You could have said, oh, well, the total length would be 6x minus 7 plus 5x plus 1. And if I add that all together, and sorry, I should probably put those in parentheses. It won't. It doesn't matter with plus, but you got to be careful with that. So if I add this whole the measure of that segment plus the measure of this segment. So ultimately the parentheses don't matter, so then we can add the 6x and the 5x, combine those like terms, so we get 11x, and then negative 7 plus 1 is minus 6. So we could actually have plugged our 8 in here, since this would be equal to the measure of dg. dg is equal to, if you add up all those x's and all those units, 11 x's minus 6 units, plug 8 in, and so we would get 11 times 8. So I'll show that real quick. 11 times 8 minus 6 would be 88 minus 6 would be 82.